Welcome to this short recorded video that will go over a gentle introduction to widgets, and this is the second video within the Part C lecture notebook of the third module for this class. So widgets are something that we will see and use rather extensively in the fourth module for this course when we're discussing computational applications. We'll also see them quite a bit in other aspects of this course from here on out. So we use this particular lecture as an opportunity for you to get familiar with what widgets have to offer. Widgets allow us to create interactivity with functions. They are very useful for illustrating concepts and exploring ideas. In particular, they're incredibly useful when we are visualizing the impact of results or choices we make in plots. So there's some links I provide here so you can read more about how to use, for instance, the interact functionality within a widget, and you can also see some different options for widgets in this link. So you should spend 10 to 15 minutes or so in exploring what these links have to offer and doing some work on reading this. But you should also read through the code cells here. I'm not going to read everything for you, but I am going to hit some highlights. So they're interactive. So we're looking at interactive Python widgets, and from the interactive Python widgets, we are going to import the following things. Interact, and you'll see us use interact in the next code cell, interactive, fixed, and interact underscore manual, which we also see here. We don't necessarily use all of these. It's just kind of a standard set of things to import. And then in particular, from the IPy widgets, we import IPy widgets simply as widgets so that we don't have to write IPy widgets every time. So I run that code cell. Now these things are imported. And now my function, remember this is the function from above. So this was, if I scroll all the way up my fun, this was the plot of my function that we saw when we were looking at derivatives early on. It was this exponential of negative x squared times sine of pi x. So I am now going to do the following thing with this function. I am going to interact with it, whereas the input, it has one parameter, input parameter x, and I'm going to use a float slider where I'm going to specify a default value, a min and max values for which I want to let x vary, and the step size from which I want to vary x in that range starting from that value. So when I run this, you will see here is the output of the function. If I evaluate that function at 0, this is the output I get. Now look what happens as I move this slider around. It is a floating point slider. If I make a 0.1, I get to see the output of the function immediately, 0.3059 and so on. And I can go up to 0.2, 0.3. These are the increments of step 0.1. And if I look at what the range is, I can go up to 2, that's the max, and I can go down to -1. And you can see what these outputs are. And it's about 0. It's -4.5 times 10 to the -17. So we'll call that 0. Now, you don't have to necessarily move the slider. You could also click here, generally. Let's see if this is actually going to work. Yes, it is. And you could just input the value here. Now, I could try to maybe make -10, right? That's less than the min value. And what happens is it immediately goes to that -1 because I said the min was -1. But if I wanted to give it a value that was, again, in there, so maybe 0, I could do 0. What about if I wanted to do 0.05? I can do that. And then what happens when I start, let's try this again, 0.05. And then if I select this slider, you'll notice as soon as I click on that slider, it defaults to, it has to round it to the step size of 0.1. But I could evaluate it at, let's say, 4.3215. Oh, excuse me, that was too high. That was bigger than 2. So let me do this. 0.4325. And then it will round it to the 0.43. So I'm giving, up to 2 decimals here that it's rounding, but I'm just getting that output of like 0.43. It's going to want to round. So, but this gives you an idea of how you can see the output of the function, and you don't have to run a code cell over and over and over again to get the outputs of the function. You can just create an interaction with it using interact with the function, and then set the parameters in this case there's just one, using sliders, in this case a float slider. Now, if I run this next code cell, interact manual, here notice there's no initial output. X is set at 0, where's the output? Until I manually run interact, clicking on that button, there I'll see the output. Now I might move the slider. Notice these values aren't changing. I move it to the value I want, and then I press run interact, and now I get the value. What would be the advantage of this? Or why would you maybe want to use interact manual over just interact? Well, it could be that my function takes a while to run. And as I'm moving through the slider here, what you notice is the values are updating immediately, or it's trying to. So it's trying to run the function for all the x values as I'm moving it, and maybe I just wanted to move it to 1.4. And it maybe takes, let's say if it took a minute to evaluate for each value, that's really kind of annoying if all I wanted to do was evaluate it at 1.4. In this case, I could just say, oh, well, put it to 1.4. Now just evaluate the function. Don't worry about evaluating it. The x values all in between where I slid this slider of the x values. So that's just something to keep in mind if you start using this. We can also create the slider as a separate object. So I could say the x values I want could be defined outside of the interact function, where I just make a float slider object like I did above, and I call it the x values, and then I just say x will be equal to those x values in the way in which I interact with my function. And then this looks just like what we saw before with this one. It's just basically giving the same functionality as this, but maybe it's a little bit easier to read of the code because I'm just separately saying what each of the inputs are. In this case, there's just one for the function, one parameter, and then you're just specifying that you're making that as a specific object, and then you're saying x is equal to those x vals, which are a slider. You can also restrict inputs to be integers. So here is the x integer values being defined as an int slider instead of a float slider. Here I give it a value of 1, a min value of -5, a max of 10, and a step of 1. And so now what you see is I can, when I move the slider around, I'm just using the arrow. Like once I have this selected, and you can tell it's selected when it's basically blue like that. So you can just press there, you see it kind of like increases in size when I click on it. Now I can use the arrow keys on my keyboard to move it from side to side as well, which is what I'm doing now. So this is just to give you a sense of, maybe there's types of integer, inputs that you only want to have as int types. You should use an int slider. If you want them to be floats, use a float slider. If you wanted to reduce the step size, you could reduce the step size. Now, sometimes you'll have values of inputs that you want to have vary over orders of magnitude. In that case, you'll want to use the float log slider. And again, you should look at the documentation, start exploring these links to read more about this. In that case, I'm saying start at a value of 1 with a base of 10, which means I'm saying start at 10 to the first power. And as I move the values, what I'm moving is the exponent of this base. So it's going to go down to 10 to the -5th, and it's going to go up at a max of 10 to the first, which is the initial value I started at. And then I increment it in steps of half an order of magnitude. So these are the magnitudes I've created. As looks like now, again, you could just put this entire thing right there. You could just have that and put that right in there for this. I'm just trying to modularize the code a little bit. I run this. Now look what happens. Here's the input. It's 1. Now it's 0.316 because I'm taking basically the square root of 10. Or excuse me, not quite that. So let's see. So we go up to 1. Here we go. There's up to 10. There's my max value. I'm just moving these x values around. So you can see I'm just decreasing by orders of magnitude what's going on with this. So there you go. And then I'm just getting the different function values. Okay. So then the activity I have for you is plotting with widgets. We now do something a bit more fancy by creating a plot function that allows us some granular control over estimating the derivatives of the function and plotting results. Your job is to add comments to every single line of code here. So you could ignore this one because I already added a comment there, but add a comment to every other line of code to explain what is going on, and then interpret the results in the markdown cell that follows, which is right here. So I'll just go there. That markdown cell, add some comments. So if you just run this, I'll just show you what happens when I run this. So here is a set of h values for approximating the derivative, and n is something related to the number of points, which is an integer, and the h is a float log slider. And you can see what's going on with these plots, and then you have to try to figure out why, if I increase n, what's going on over here, and what's happening with these h values. As I shrink that down, and as I change these n values, what's going on? Why is the plot getting choppier? If I decrease n, what's going on? As I increase n, why does it look like that? And what's going on with H is I either increase H or decrease H. You should try to understand and interpret what's going on in the context of stuff before. So that's really it for this particular recorded video. And the last activity is the summary. So I'm going to create a video for the third assignment, the assignment with this module, I should say. And otherwise, I will be talking to you in lecture notebooks for the fourth module. Thanks for listening.